Hey geometry class, what I have for you in this lesson is actually two lessons in one. We're going to be looking at trigonometric ratios and applying those. And so this is section 7.5 and 7.6, and we're going to be studying about sine, cosine, tangent ratios, all three of those, okay? So let's go ahead and take a look at what their definitions are. So trigonometric ratios, sine, cosine, tangent, are known as this right here. Sine ratio, you write SIN. Cosine ratio, you write COS. And then tangent, TAN. Okay, there's another three trigonometric ratios that we could look at, but we're not going to be studying those as of yet. We will maybe look at those later on in the year, but if we don't get to them, it's not the end of the world. You will have me in trig or in algebra 3 and we'll look at them in that class too. So here are the definitions of your trigonometric ratios. So it deals with right triangles, and here we have a right triangle. Let me get my highlighting pen tool. Hold on for a second. Okay, so here on this triangle, let's just look at this one, and that deals with this stuff that I'm about to talk about. And this triangle over here is what this is over here. Okay, so sine ratio. Now, whenever I say sine ratio, you write sine, and then what always goes inside your sine ratio is your angle, okay? So I'm going to write sine of angle A. Here's my angle A on my triangle. Let me do something real quick. Whoops. There we go. So angle A, this is the angle A we're looking at right here. This right here is always going to be known as your opposite side over your hypotenuse. So how you determine what is opposite and what is adjacent and what is your hypotenuse. This you need to make sure you know before you even understand what sine, cosine, tangent ratios even mean. So let's look at this right triangle. If we are looking at angle A, opposite of angle A, meaning draw a line straight across that triangle from your angle A, this is known as the leg opposite of angle A. So this is leg opposite or opposite. The one lying against, the leg that's lying against the angle A is your leg adjacent. And then we've already determined before what is the hypotenuse. The hypotenuse is always opposite of that 90-degree angle, or you can look at it as it's the longest side on your right triangle. Always the longest side, or you can say opposite of the right angle. Okay, so for this right here, opposite and then adjacent, and then our hypotenuse. So this is how sine of A goes. It's our opposite over hypotenuse. Let's go ahead and make labels for this. I'm going to label this A, B, and C. The reason I labeled it A, B, and C, you might as well know, is because we're about to get into another section that deals with solving triangles. You're always going to have opposite of angle A, small letter, side A. And then always opposite of B, you're going to have your side B. And then opposite of angle C is always your side C. So that's how I'm going to label these triangles here. C, B, and A. All right, so sine of A equals opposite over hypotenuse, or you could say A over C. Now let's look at cosine. Very similar, but it deals with two other sides of your triangle. One being the same, just the hypotenuse, but the other one is your adjacent. So cosine of angle A is your adjacent side to angle A over your hypotenuse. So B, in this case, over C. And now our tangent ratio of angle A is our side opposite of angle A over the adjacent. So opposite over adjacent is what we call it. In this case, it'd be our A over B. Okay, so these are all of our tangent ratio or trigonometric ratios for angle A. Okay, but now what if we change it to the other angle that is in our triangle? What if we are given the other angle? So that's what this other triangle over here is for. Let's look at angle B now. So what's going to happen is your adjacent and your opposite sides flip with each other. Your hypotenuse is always going to stay the same, but see, opposite of angle B now, we have this side rather than this one over here. So this becomes our opposite of angle B, and this becomes adjacent of angle B. So whenever we say sine of angle B, we have opposite over hypotenuse still, but now it's B over C. And now let's look at cosine. Cosine is the adjacent over hypotenuse. So now adjacent of angle B is side A. So A over C. And then tangent of angle B is your opposite over adjacent. So opposite is B, adjacent A. So now you have B over A. So just depending upon what type of, depending on what type of angle you are given, the A angle or the B angle in your triangle, that depends, it helps you figure out what is your leg opposite and what is your leg adjacent. And that is going to help you in solving some triangles that we're about to solve here in a little bit. But first, let's just look at finding the sine, cosine, and tangent ratios given numbers of for all three of our sides of our right triangle. That's our next example. Okay, this triangle right here is considered solved already. It's just asking for what are our ratio values for sine of A, cosine of A, and tangent of A, and then again for angle B. Same thing. So, looking at this triangle, knowing all three sides of our triangle, let's figure out our ratios for sine, cosine, and tangent of angle A. So angle A, first thing you need to do, determine which side is opposite and which side is adjacent, and you should know which one's hypotenuse already. This is always going to be your hypotenuse, the one opposite of the 90-degree angle. But here we have opposite of angle A is our 45. So this is our opposite. So this makes 28 over here, our adjacent. All right, so let's put them all together. Sine of A, opposite over hypotenuse. So 45 over 53. And in your homework, whenever you're applying these ratios here, go ahead and reduce it as much as possible. But here I'm not going to worry about it, just for time's sake. Okay, let's look at cosine of A now. Cosine of A is your adjacent over hypotenuse. Okay, so adjacent 28 over hypotenuse 53. 28 over 53. Okay, now let's do tangent. Tangent is opposite over adjacent. So opposite 45, adjacent 28. All right. Now let's switch over here to angle B, finding all of our trig ratios for angle B now. So I'm going to erase all of this up here, except our hypotenuse. That doesn't change. But the sides opposite and adjacent are going to switch around. So here's angle B. Opposite of angle B is now 28. So this is going to be our side opposite, and this becomes our side adjacent. All right, and real quick, before I move on to all of these ratios, I want to tell you something. You may have heard me mention in class in passing, and a lot of you kind of gave me weird looks, but a way that you can remember these definitions, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, is with one word, SOHCAHTOA. And this is how you spell it. SOHCAHTOA. And what you do, you split it in threes. What this tells you is that your sine, this right here, is equal to your opposite over hypotenuse, just like this. And then cosine is equal to your adjacent over hypotenuse. And then your tangent is equal to opposite over adjacent. So this is just a really nice way in one word that you can hopefully remember. Kind of sounds like an Indian word, SOHCAHTOA. And it's just very easy to remember. Just remember how to spell it. If you want to enunciate it in a different way to help you figure out, okay, that's the way I'm going to spell my SOHCAHTOA, then do that. Just remember that, and it will help you remember all of these trig ratios that we are learning about. Okay, so now that we looked at that, let's take a look at this right here. Sine of B, opposite over hypotenuse. So opposite 28, hypotenuse 53. And then adjacent over hypotenuse for your cosine. So 45 over 53. And then lastly, tangent of B is opposite over adjacent, so 28 over 45. And that is it for our trig ratios. Next, we are going to look at some examples of solving some triangles. Not completely solving triangles, but we are going to be looking at finding different sides of our triangle. Okay, this example right here, I'm going to actually leave for y'all as a little quiz at the end of this lesson. Try to do this on your own at this time, and we will look at it together when I see you next. Okay, so let's move on to our next example, which is the solving of different sides of our triangle. All right, so these examples here, whenever you're asked to find the value of x, which is a side of our triangle, to the nearest whatever number, 10th here in this case, we're going to be using our trig ratios to help us find our side lengths that we are asked to find. And but inside our trig ratios, instead of just finding the ratio, we have an angle to put in for either our A or our B value. So remember, before we were looking at sine of angle A, but in for this A now, we're going to put our 50 degrees. Okay, and sine of 50 is just a number, and I'm going to show you how to input that into your calculator here in a little bit. Okay, so let's take a look at how to solve this first one. So what we do is we determine what sides, according to this angle that we're given, do we have. And according to this angle, this is our side opposite. and this is our side adjacent. Okay, now remember the SOHCAHTOA thing. I'm going to write that up here. Now, which one of these trig ratios has opposite and adjacent in it? And the answer would be tangent. So the tangent ratio is what we're going to use to help us in figuring out what x is equal to. And this is how. We're going to say tangent of our angle that we're given, so 50 degrees, is equal to our trig ratio, opposite over adjacent. So 13 over x. And now we solve this for x. Like I said before, tangent of 50 degrees is just a number, so treat it as if it's a number. Don't put it in your calculator yet and solve for that decimal answer that you're going to get. Just what we're going to do here, since our x is in the denominator, here's just a quick and easy way to remember how to solve for whatever your value is if it's in the denominator. You just want to switch these values around. Okay, you can treat it as if it's a number over 1 and do cross multiplication if that helps you think about it that way. But what I'm going to do is just switch my, my tangent of 50 with my x, and that will get me the same value. So x equals 13 over tangent of 50 degrees. Now we're going to plug it into the calculator and get an approximate answer for that. So let me bring up my calculator. All right, one thing I do want to tell you before we start plugging anything into our calculator, if you have a calculator like this right here, an 83 or 84, the first thing that you need to do is go to your mode button and look here. If it's on radians, you need to switch it to degrees. And how you do that is just you go down to this option, go over to degrees, and click enter, and now your degrees is highlighted rather than the radians. And then from there, just hit second mode to quit and get out of that the mode area. Now that it's in degrees, because we are using degrees, not radians. You won't learn about radians until we get into trigonometry. So here's how we do this. We're going to input 13 divided by tangent of 50 in our calculator. So 13 divided by tangent of 50. And you don't have to put degrees on it because we are in degree mode. And just hit enter. And there you go. Our answer to this right here, approximated to the nearest tenth, will be 10.9. And that's it. So let's write that down. 10.9. There you go. We found what x is equal to. Now let's do the same thing on number 5 here. Again, let's start by figuring out what sides we have according to the angle that we are given. So angle 24 here, opposite of it is 9. So this is my opposite. And adjacent to it is the x. So adjacent. So here again, we are going to be using the tangent ratio because we have opposite and adjacent. Can't talk. Sorry, people. Adjacent. So tangent of now our angle here that we're going to input inside tangent is 24 degrees is equal to opposite over adjacent, so 9 over x. And again, we have the same situation here as we had before. Switch around tangent of 24 and x. So x is equal to 9 over tangent of 24 degrees. So put that inside your calculator again, just as we did this one here. And what you're going to get is 20.2. There you go. We found x. Okay, this last example here on this page, again, let's solve for x. First, find the sides. This is our opposite of our angle that we're given, so opposite. And again, adjacent. We'll have some examples here in a little bit that use the hypotenuse of our triangle, but not right now. These are all dealing with our tangent ratios so far. Okay, so tangent of our angle 41 is equal to opposite, so opposite this time is x, over adjacent, which is 16. Now to solve for x, in this case, since our x value is in the numerator, we need to multiply both sides by 16 to cancel it out from this side. So x is approximately equal to this right here. So we're going to plug that into our calculator, and I'm going to show you how to do that. Okay, so here is your calculator, and what you put in is simply 16, and you can say times here, but it's not necessary. It's understood to be times whenever you put in tangent, cosine, and sine in these after your number. So 16 tangent of 41, and hit enter. And there you go. Our value for x here is now 13.9. So right in here, 13.9. We are done. So there you go. You are on your way to solving triangles now. All right, again, we're going to solve for each variable. This time we have two variables to solve for on each of our triangles. So here, we're going to have to use probably our sine and our cosine values to help us in, and tangent, all three of those, to help us in figuring out these variables on these triangles. So again, I'm going to write my SOHCAHTOA up here at the top because it helps out quite a bit. Okay, now, sorry, go away, there we go. Here is our angle that we're given. So let's label our sides. This is opposite, and the other leg is adjacent, and this is our hypotenuse. Okay, so let's go ahead. You can solve for A or B in this case. It doesn't matter which order you solve it in, but I'm just going to start with A. And for that, let's look at this. Our angle opposite, or our side opposite, is 14, and we have that value, so let's use it. And we're looking for A, which is adjacent. So opposite and adjacent. Again, we're using tangent because it has the opposite and adjacent in it. So tangent of our angle 57 is equal to our opposite, which is 14, over the adjacent side, which we're calling A. Okay, switch these two. So we get A is equal to 14 over our tangent of 57 degrees. Now, approximate that by plugging it into your calculator just as I've shown you previously. And when you do that, you get 9.1 as your answer for A. Now, to solve for B, instead of using A, which is an approximated answer, always go back to the information that you were given in the first place. So don't say, well, I can solve for B using side A that I have solved for previously. Always go back to the information, which 14 and angle 57. Always go back to the what information is given to you from the beginning. Okay, so in that case, what I'm going to tell you here is we have opposite and we're looking for hypotenuse. So up here, opposite and hypotenuse. This is the trig ratio that we're going to use to help us in solving for our variable b because it's using opposite and hypotenuse. So let's do that. So sine this time of our angle 57 is equal to opposite over hypotenuse, so opposite 14, and then the hypotenuse, which we're calling b. Now solve this for b. B is going to be equal to 14 over, remember, switch these variables, these values around, and it gets you 14 over sine 57 degrees. Plug that into your calculator and you will get, let's see what I got, 16.7. And there you go. You have solved this triangle for the sides that you are looking for using your trig ratios that we just learned. Okay, so this is how we're going to do the rest of this lesson here. We're going to solve for our sides that we have variables to it. Okay, so let's look at number 14 here. Just keep on going. We have, again, this angle right here that we're given means that this side right here is opposite. And this side here, adjacent. And opposite of our 90 degree and the longest side on our triangle is our hypotenuse. Okay, so now what we have in this case is almost exactly what we had before. We're going to be using our tangent to help us in solving for C because we have opposite and adjacent. Tangent of 41 degrees equals our opposite, which is 17, over adjacent, which is C. So now C is equal to, so solve for that, it's going to be 17 over tangent of 41. Plug that into your calculator, get an approximated answer, which is going to be 16.1. And now let's do finding the side D here. And this is our hypotenuse. So again, go back to the information we're given, which is 17. And that's our opposite over hypotenuse. Opposite and hypotenuse. Again, we're using the sine ratio. So write it out. Sine of 41 degrees equals side opposite 17 over hypotenuse, which is D. Solve for D. So D is equal to, let's see, 17 over sine of 41 degrees. Plug that in your calculator, and what you get is 25.9. And there you go. You have solved it. Now on this next one, again, I'm going to have you do this third example all on your own. We'll look at it in class together when we get back. Let's move on to examples 16 and 17. And then again, I'll have you do number 18 on your own. Okay, again, solving for the variables. Let's look again at our angle that we're given and determine the sides. This is going to be our opposite. So this is going to be our adjacent, and this is our hypotenuse. And to solve for this one, okay, we are given the hypotenuse this time. Previous times we were given one of these sides, the adjacent or the opposite. So it changes things up a little bit. We are going to do this. We could either solve for T or U again, either direction, doesn't matter which one you choose first to solve for. But let's go in alphabetical order. Let's do T. T is my opposite, and I'm given hypotenuse. Let's write this out again. Oops. Stop. Okay. Toa. All right. Hypotenuse and opposite, that's this trig ratio right here, sine. So let's say sine of our angle given, which is 51 degrees, and that's equal to our opposite over hypotenuse, so T over 32. And again here, since our number's in the numerator, what we need to do is get rid of our 32. So multiply 32 to both sides to cancel it out over here. And T is equal to, plug this into your calculator, 32 times sine of 51. And make sure you do it like this, 32 over here on this side times sine of 51, and do not put anything inside your sine function except for your angle, okay? Never multiply any numbers through to inside of your function or divide anything either. 51 belongs inside of sine only. Later in trigonometry, if you have me then, we may be dividing things inside of our sine function, but that is way more advanced than what we're doing right now, okay? So just leave your angle alone inside your sine function, cosine function, and tangent functions. All right, so plugging this into your calculator, what you get is 24.9. And we're done with that one. So now let's find U. U, in this case, are side adjacent and side hypotenuse, adjacent and hypotenuse. That is our cosine function. So here, let's use cosine. So cosine of our angle given, 51 degrees, is equal to, look at it, adjacent over hypotenuse. So adjacent, U, over hypotenuse, 32. Okay, so now, again, just like before, multiply 32 to both sides to get U by itself. Okay, you may think, oh, this is going to give me the same value. No, it's not. Sine and cosine, unless you have the same angle on the, like if you have 45 degrees on the inside, like it's a 45, 45, 90, you are not going to get the same answer. Sometimes you might get close, like this one right here, this triangle, it's close to a 45, 45, 90. So our legs of our triangle, the answers are going to be close to each other. But that's only in the 45, 45, 90 triangle cases. And we don't necessarily have to use sine, cosine, tangent for those. We can just use our theorem that we've previously studied. Here we go. Let's put this into our calculators and solve for U. So U is approximately, whenever you plug that in, 20.1. There we go. We solved that one. Now lastly, let's do 17. Like I said, you're going to do this one by yourself. So 17, we have, here's 47, the angle that we're given, and opposite of it, so side opposite, and this is our adjacent, and this is our hypotenuse. Okay, now let's do this again. We're going to say we have angle 47 and opposite of it is y, and we're given the hypotenuse. So hypotenuse and opposite, that's our sine function again. So let's use sine of 47 degrees is equal to opposite over hypotenuse, so y over 12. Okay, again, our variable is in the numerator, so multiply both sides by what's in the denominator to cancel it out. Plug this into your calculator, and you get y equals, let's see, 8.8. And we're done finding y. Now let's find x. So x is our side adjacent, and we're given hypotenuse. So adjacent and hypotenuse, again, we come back to the cosine function. So let's use cosine of our angle 47 degrees is equal to the adjacent over hypotenuse, so adjacent x, hypotenuse 12. Multiply both sides by 12, and you get x is equal to, when you plug that into your calculator, you get 8.2. So see there, look, like I said before, 8.8, 8.2, they're very close to one another, and that's just because we're very close to having a 45, 45, 90 triangle. And that is the only case where you'll have two legs that are equal to each other, is in that 45, 45, 90. But there you go. I am done with this lesson. You all do the rest on your own. So guys, I will see you all in class. Goodbye.